Today, our speaker for this session is Mr. Babulpreet Singh, Junior Scientist at Tetris Data. Sir has an expertise in conversational AI bots with a 2+ year experience in MIAL industry, with an expertise in dialogue assistant development using RASA and AWS Lex framework. Now, I would request Sir to take over the session. Yes, sir, you'll be made the co-host in a minute.
Okay, sure. Yeah, good evening, everyone. Thank you very much for the opportunity. Today, I will be talking about basically the conversational AI agent, which we are building under the Circulated Punjab project under Support Foundation. So yeah, we will begin. Let me share my screen. Am I audible clearly? Can anyone please confirm?
Yes, sir, you're audible.
Okay, thank you. Okay, so is my screen visible?
Yes, sir, the screen is visible.
Okay. I'm stopping a video while presenting. I will turn it on once my presentation is complete, and I will be like turning my video on in the QA session. Will it be right? Because I think there's some issue with the internet because it's a bit disturbing here. Will it be fine? Hello.
Yes, sir, that will be fine.
Am I audible?
Yes, sir, you are.
Okay. Thank you. Okay, so basically, I'm basically concerned with building this agribot. You can say as Sathi. This is a part of a project which is under development under the Support Foundation. It has 5 major components: the farm monitoring module, crop and disease identification, IoT, mobile application, and a chatbot. So in today's session, basically we will be covering whatever we are doing in concern with this chatbot module. So starting with that, before that, I will just want to give a brief whatever we will be covering today. So we will start with the problem statement. Then we will discuss how we are trying to solve it. What is actually a chatbot? Some agriculture bots that are present in the market. Then we will touch base upon the technology which we are utilizing, and we will talk about why that technology is superior than whatever is being utilized in past, and how our bot is different from them. Then we will discuss whatever work we are doing now, how that will gonna affect the farmers. And after that, we will look into the flow of a chatbot, which our chatbot is right now utilizing. We'll have a glance at our bot. Then 4 major areas which require support, which we came to know after analyzing the data set which we are utilizing for building this conversational AI agent. Then we'll like to share some real world story, or you can say a case study or a scenario where I will discuss like what happened due to the lack of knowledge with the farmers. Then we will touch base upon this the ultimate aim of building all these different components, and then have a look at how far we have come. And then at the end, we will be having a future scope. And after that, I will be open for the QA session. So starting with the problem statement, as we all know, like the farmers, the people, or you can say the folks in the agriculture sector, those who are having a profession as a farming, they are not very much educated. So although the new people which are coming into this field are getting educated and having degrees and everything, but the old professionals, like the old farmers which are working in this field, they lack knowledge to some extent. So as per the reports of November 2020, around 58% of India's population earns primary source of living from agriculture. So it covers a major chunk of the population. So close to 10,000 farmers every year come due to the harsh conditions in the agriculture sector. Somewhere it's due to the irrigation, somewhere it's due to the diseases, or somewhere it's like not having a proper knowledge and accurate knowledge about how to do farming. Somewhere it's due to deficiency of some minerals in soil which they are not aware of. So things like that, which like result into not having a desired yield which they want to have, and which further leads to large, you can say, loans on the farmers and several other issues, which might further leads to the societal cases as well. So, so all of these things is happening because of a few key factors which we have identified. Like first out of them is the lack of knowledge. Lack of knowledge further have various components, like they are having lack of knowledge about the fertilizers which need to be used. They are having lack of knowledge about the insecticides to be used. They are having lack of knowledge about amount of manure to be consumed, what kind of manure to be consumed for different kind of crops, what different diseases which are nowadays they are experiencing. So they are not aware about, like, okay, the names of the diseases, why that disease comes up, how to tackle that, and everything about the new varieties. Although nowadays, as we all know, like a lot of research is going on in the agriculture domain. A lot of scientists are building uh, hybrid seeds, and they are generating these seeds so that the farmer can have a good yield. But the thing is, the farmers are not aware about this new variety of the seeds. So there is not a proper medium so that they should get knowledgeable about what's going on, or what's the new that's coming up in the market. And even if we talk about the recommendations, so they are not having like an access to experts who can recommend them the the fertilizers, how they can control the diseases. And also they need a source for the continuous knowledge upgradation as well. Farmers actually hesitate to talk about their problems, and they even don't know how to explain what they're going through. Sometimes this is also a scenario, and they actually require a source, a real-time solution on the go, which is also readily available, but in addition to that, also be validated by the experts so that they can blindly trust it. Because what's happening nowadays is they either talk to their fellow mates, or they went to the local vendor from where they purchased the stuff. They got advice from them. So that is not unbiased or trustworthy advice, we can say. That is somehow biased towards the vendor, or um, biased towards whatever the knowledge his fellow mates are having. So that's a problem which we have identified. Then there is a need to have a single point of opinion, and there is need of a source to educate them how different factors contribute towards the yield improvement. And also all these factors, uh, all these problems which we have identified, uh, we come up with the solution of building something called a conversational AI agent, or you can say a chatbot as well. So the goal of making this chatbot will be to provide a 24/7 support, or you can say whatever the name which we are utilizing for our bot is Sathi. So there is Sathi available with them 24/7, to whom they might ask any sort of question, any open-ended query, uh, anything which they feel about their crop, their yield management, the diseases which is affecting their crop, like any query related to the agriculture domain. In spite of having access to the local vendors and even the fellow mates, but they can ask about, like, okay, if someone is facing some issue, he want to talk about like, okay, how can I improve more on that? He wants some advice, he wants some clarity about what he's doing. So everything that will be covered by this bot. So for like talking more about how it will affect and everything, first let's know like what is a chatbot. So chatbot can be defined as an AI-based computer program that simulates human conversation. So they are also known as digital assistants, conversational AI assistants, or conversational bots that understands human capabilities, that understands human conversation, human intent, whatever the human trying to say, and respond accordingly, and provide a relevant answer to them. But the thing is, whatever the answer the bot will be providing will ultimately will be depending upon what the bot is being taught beforehand. So it's very important to have a good knowledge base around the bot. You must be having a clear picture about regarding what problem you are building a bot, what problem you are trying to solve, so that your knowledge base must be enriched with all the solutions, if not all, at least 90% of solutions. And by having them there, you can rely upon your bot, like, okay, if a user is asking any query in any form, you will be able to answer it with the help of different algorithms and different stuff available in the market related to AI domain. Bot can communicate through voice as well as text, as we know. So if we talk about the voice assistant, so majorly we have seen like voice assistants are available in English language and in the abroad different countries, right? But it's not available in the native languages, like if we talk about Punjabi, Hindi, or even Kannada or Telugu. So the state-wise native languages are not having voice assistant supports. So although they are having a Kisan call centers where they can call and talk and have their queries solved, but that's not sufficient for them. That's not 24/7 available to them. So in that case, this bot will be having the support and can be deployed across various websites, various applications, messaging channels. So like right now, like Facebook or this Instagram or Telegram, they are not much, but they are, we can say Facebook is very much popular. So these social integrations are very easily, can very easily be done with these bots, and farmers can utilize these bots there. So it will be very helpful for them. If I talk about some of the agriculture chatbots that are present in the market, so there are three which I have shortlisted, although there are many other as well, but for the sake of comparison, I am having three different kind of bots that are available in the market. The first one is the Agro Expert Farmer Assistant. So it utilizes a chatterbot. It's in a Python library. They have utilized it to create a application. It's based on machine learning, where they are just doing the matching of the questions with the answers depending on the queries they are having in their knowledge base. So it's just kind of FAQ bot, you can say, frequently asked questions related to some topic. Then we are having a farmer bot. So the main aim for this bot is to again handle the basic queries, but the thing is it is only related to the potato crop, or we can say it's only related to the potato farming. It utilizes the framework IBM Watson conversation dialog flow to build their bot, and they are having other various aspects related to that, like the plant protection, we can say, the fertilizer usage, the weather conditions, and different aspects they are covering, but they are only covering it in regards to the potato crop. Then comes this Krushi, the farmer chatbot. This is the latest one which is being widely used. So it utilizes again the artificial intelligence techniques, machine learning techniques. They are using the Rasa. Rasa is an open source. We will touch base on that in the coming slides. So this bot is utilizing, but what's missing in it is the multilingual support, we can say. It's not there. So how our bot will be much more better than this bot is, there are 2 points which I will touch base upon. The very first one is we will be handling the code switching. So what is code switching? Code switching will be something whenever like a person is interacting with the bot in some language and he suddenly started typing in another language. So the bot will going to understand the user's intent. It will going to respond him accordingly what he has answered, in spite of like providing him with buttons or something like you have to first select to the language, go to that part, and then you will be answered. So it will understand whatever the query user is asking in any language, and what all in any language, and will providing him the response to that. Also, in addition to that, if person is typing a text in mix of two languages, at that point as well, he will look into the different words in the sentence and will see which language is dominating in that sentence. So in that particular language, the bot will be providing the answers. So that's a area of research which is also going on. So to some extent, we can say about 80% of accuracy we are achieving in that. So that's a major difference which will be present in our bot. After that, we will be, as I've said, we will be providing a multilingual support. So bot will be present in English, will be present in Punjabi, will be present in Hindi for the time being. But in coming years or in after further upgradations, it will also be supporting other native languages as well. So that will keep that will make our bot more sophisticated than what's being available in the market. Moving further. Here we can look at the basic working of a chatbot. Despite of any framework you are utilizing, whether it's Amazon Lex, whether it's Rasa, whether it's IBM Watson, whether it's Google's dialog flow, any framework, this is a basic flow which each and every framework follows. So what will going to happen is, let's say user or a farmer is going to ask a question. The framework will basically going to analyze the chatbot will gonna analyze the user's request. Once it analyzes that request, it will gonna identify the intents and entities. So here intent means intent of a user, what user wants to say, what other important information a user is providing in its utterance, what he has said to the bot. After getting that, accordingly, it will gonna make a decision and provide a simple response back to the end user. So it's a basic, a very overview kind of a flow. Then we'll talk about the technology used for making chatbot. So this is here we will touch base like upon Rasa. So we have utilized Rasa. Firstly, what is Rasa? Let's discuss, and then I will talk about why we chose Rasa rather than any other. So Rasa is an open source framework for developing conversational AI agents. It's incredibly powerful. It provides us support to customize different aspects, different components. It helps us to integrate it with any of the social platforms, websites, mobile applications very easily. Even if we talk about the main modules, without going into much detail, if we talk about the main modules of Rasa, it's having NLU, Rasa NLU part, and a Rasa core part. And what Rasa NLU means, natural language understanding, which understands the user message. Whatever user is trying to say, it understands that message. Then comes the Rasa core. It is basically for holding the conversations. If I'm talking to bot, I might be providing different utterances. I might be switching my conversation depending on whatever is coming in my mind. So keeping the track, keeping a history about what user trying to say, that everything will be stored in the Rasa core. And after analyzing that, whatever user will be entering next, the response will be provided back to the user. So this Rasa core part handles that thing. Now, what has happened in the latest release in past 2-3 months, when Rasa 3.0 is released, they have basically merged the Rasa NLU and the Rasa core source code, and now it's being considered as a one component which is doing both the jobs. Then they also have one product called Rasa X. This tool helps us to basically visualize and annotate different entities in the user utterance. It helps us to we can say deploy as well. It provides us a REST API which we can use, and with the help of which we can deploy our chatbot. If it's an optional thing, we don't have to utilize it every time. So either you can create a Docker file and you can deploy it, or you can use render for deployment. So there are other components, or you can say there are other options also available for deploying your chatbot. So it's not a mandatory part, but yeah, it's a good thing to utilize. Then let's have a look at how Rasa works internally. A bit of let's suppose the person asks what's the weather tomorrow. So what happen will be this part is being set to Rasa. Rasa will gonna see, okay, the intent of user's query is weather query. He wants to ask about the weather, right? So this intent will be defined by a developer somehow. And Rasa model, once it's being trained, it will gonna catch like, okay, this is what user is trying to ask about. Then once that part is done, it will also be fetching the entities, the important piece of information from the user's text. He fetched like, okay, so he wants to know about the weather tomorrow. Then he looked into its database or CRM integration, like depending upon the query, what will be the best suitable answer. When it looks into that part, it finds like what should be my next action. So while making a decision, we will see in the next slide what's dialogue management part. So what it will be doing is it will see, okay, I have to tell him about the weather about tomorrow, but I'm not knowing like from which place I want to tell the weather status. So the next question will be location question. So it will make a decision depending upon the data or a knowledge base it's having in its database, and then we're going to ask a question, where are you based from? So in this way, the conversational AI agents are better than the FAQ bot. So if they hear FAQ bot will be present, so it will gonna run the fallback policy saying like, we are not having appropriate answer to this question. So can you please rephrase? So it understands the user misses some information. I need to get that from the user, and accordingly, I have to provide a response. So it will gonna ask the location and then will providing the accurate temperature by either hitting a weather API or whatever the person or the development team is utilizing. Then comes a bit of, I will say, a bit of more detail into what this rasa part is holding, which is written in blue parts. If we explore that a bit, let's suppose I send in a question, how can I control wheat from basmati rice? That question will first gonna send to connector modules. So now what is connector module? Connector module is something which is joining my chatbot's model, or you can say which is joining my chatbot to a user interface. If I'm using an application, I'm using a social platform, I'm basically attaching my bot to that part. So whatever user will be entering, that will first pass through the connector module. Then it will be sent to the input modules. So input module is something, the machine learning model which is being trained at the back end, which will gonna make decision and doing everything. So it has different parts. For the sake of simplicity, we have named them as ear, brain, and mouth. Talking about the ear, a user has entered a query that is being passed through connector module. It is being sent to the input module. Input module will act as a ear. It will listen to whatever a user is saying. Then internally, it will understand. That's why we say like natural language understanding what user is trying to say. Okay, then it will pass that part into the dialogue management. Then dialogue management will be knowing this is what user is trying to say. So depending upon its request, what should be my next action? What should I be doing? What should be my stake on that? Okay, so it will build a decision about what user is asking. We'll look into its APIs, we'll look into database, we'll look into all the knowledge base which it's having, on which it's being trained, and what should be the most appropriate thing. It will come back with that part, make a decision, and send it to output module. Like you have to do this according to what user has said. Output module part is known as a mouth. Why mouth? It will gonna tell back the user, okay, so this is being asked and I have to respond back to the end user, whatever the solution to its problem, its query, its whatever the solution we are having to the user entrance. So it's basically, that's why known as natural language generation. Here we are generating a response to what user is trying to say. So firstly, we understand that part, natural language understanding. Dialogue management, making a decision, having a clarity about, okay, this is what user has asked, this is what I have to do now, this is the response to that query, sending back to the output module, to the mouth. It will gonna generate it in a suitable form so that the end user might understand that and will gonna pass through it the connector modules to the end user. So in this way, the whole process of this conversational AI agent works. I hope it helps everyone to understand, like on a very overview kind of thing, like how these things internally work. Although we are not touching upon the ML models and every technique which is being utilized at the backend in the dialogue management, because that will gonna be too technical for the session. So moving further, these are the social platforms or the integrations which I was talking about. We can connect this chatbot to the website, to the Facebook Messenger, to the Slack, to the Rocket Chat, Telegram, right? And even customize, you can say, mobile applications and everything. So we can very easily do that. Now comes the part which we can say which holds the most importance. Okay, we are doing something, we are building something, that's fine, but how it will gonna affect the farmers? That's the ultimate thing. So talking about the benefits, the very first one will be the cost saving. Second one will be the saving time of a farmer. Third one will be having something we call a reliable resource for a farmer on which farmer can rely upon. Then we will be having a 24/7 support system for the farmer. So he shouldn't be feeling like, okay, so if I have to do something, I'm bounded by some time interval. So 24/7 support, up-to-date information, and support. Although support is being there, but it will also be in its regional language. So multilingual support will also be present. If I explain about those points a bit, so if we talk about the cost saving, it provides a clear idea about what to do, how much they need to spend according to their soil type. So rather than going to sorry, rather than going to local vendor and asking him, okay, so this crop is I'm basically sowing, provide me with the fertilizer. So he will randomly saying like, okay, I'm getting benefit from this. Let's make him we can say full, not completely full, but yeah, let's give him whatever he want in any amount, because he's not aware of how much he needs and getting his own benefits out of that. So by having a clear picture about the soil, the true condition about what soil actually needs, what's the deficiency of soil, what soil is enriched with the minerals, what minerals are in adequate amount in the soil. By having that clear picture, the farmer will gonna buy only the required amount of fertilizer, and it will definitely gonna help him save the money, hard-earned money. Then it saves time, as I've said, whenever it's a sowing, although the Kisan call center is present, but whenever it's a saving time, sowing time and harvesting time, there are a lot of calls that they are having a waiting of about 1 hour, 2 hours. So at that point of time, if they want to ask something, if they're like they're in the market and they want to buy something, so they can't afford to like wait for so long, and they just ask the local vendor, okay, what should I do? So they somehow get affected by their advice. So the bot will gonna save their time. It will gonna have a very quick response to them, which will not only be like having a response, but also a response which is backed by the domain experts, which they can totally rely upon, which again like covers up over the next point, that reliable resource will be there. So they can blindly rely upon that, because that source not only will be backed by farmers and will only be like it's built once and they are utilizing that part, will gonna be updated again after regular intervals. So the information which they will be getting from the bot will be very accurate, very up to date, depending upon the current scenario, whatever is going in the market, whatever is going around the globe. So everything will be updated. Then 24/7 support, as we already discussed, and the last one is the multilingual support. So they can ask the question, they can type, otherwise they can also speak, you know, in whatever their native language, and they will gonna be getting the desired response out of it. So moving next, you can have a look at the bot which we are building, how it will be performing. We will also have one more diagram explaining explaining this flow in a bit detail. So what's happening is it's providing two buttons in very first, like whether user wants to ask questions from agriculture sector or horticulture, and then user can ask a question. Sorry. So what's happening, let me explain through this one, it will make things more clear. So let's suppose the bot appeared with the two buttons, and user selected, okay, I want to go with the agriculture. User entered a query, the bot provided the response. Then what, let's suppose after having some conversation, a user wants to ask something about other crop, right? And he right away asks the question, the bot will gonna provide him the response, but in turn it will tell us by understanding the user's utterance, like you have asked a question from horticulture sector, this is its answer. You want to continue with this sector, you want to ask query from the sector, well, that's good. But if you want to switch to any other sector, you can select it from the button. So it will not be like having a constraint. If you have selected something, you have to go into that direction, and again, if you want to use something, you have to refresh and select that category and then start the docking. So it will be a real-time updation. You want to ask something, you are having an ongoing conversation about something, then you want to switch it to another part, you can ask that, you will be gonna getting the answer. You want to continue, you are happy to do that. You want to switch, you can select the button. So in this way, it will be more helpful to user. It will be more easy to operate for them, and they will be having something which they can rely upon. Then you can have a look at our bot. So here you can see like we have covered few crops, and these are the queries which we have asked to our bot and how it's performing. Yeah, here's a query like, how can I control weed from basmati rice? How can I, like by spring, what can I get rid of bulb from the rice crop? There are other different questions like how to handle pink caterpillar in a wheat crop, how do I control deficiency of something in some crop, you know. And also you can look at the bot which is in Punjabi language, which has been completed for few crops, but yeah, it's ongoing. Like the question is, metro ne vich phosphorus di ਘਾਟ ਨੂੰ ਕਿਵੇਂ ਸਹੀ ਕਰ ਸਕਦਾ? Now the bot is being responding with like ਝੋਨੇ ਦੀ ਫਸਲ ਵਿੱਚ phosphorus ਦੀ ਘਾਟ ਨੂੰ ਪੂਰਾ ਕਰਨ ਲਈ 1 kilogram powder NPK, whatever the ratio is required, whatever the water is required, the adequate amount, it's providing a response to the end user. So it's very straightforward, very open-ended, not being confined by different things. You just have to select the sectors, you just have to ask the questions, you will be getting the response out of it. Moving further, now I will like to touch base upon basically the data set which we have utilized. So four major areas which comes up after analyzing the Kisan call center data. So what farmers are asking in bulk is like about firstly protecting their plant. Then we can say they're also asking question, it's although it's a sub part of plant protection, about the pests and diseases which they are being affected by. Then the best practices about each and every crop. We were having questions around. Then the major concern also was about the unbiased recommendation on the products. They are very much concerned with like they are not having any good access to agronomists where whom they can ask, or domain experts whom they can ask about their queries. They have to wait, they have to rely upon somehow on the local vendors, the friends advice, fellow mates advice. So something like that. So talking about the plant protection, approximately 60 to 65% of the agriculture calls were dedicated to protective measures. The pest control and disease, what we have figured out after analyzing is like farmer is not knowing the name of a disease. Farmer is not able to explain clearly what's the problem with the disease, what's the name of the disease. So what the domain experts have to do is ask few questions to and fro, and after analyzing what they're trying to say, they can understand that part and respond accordingly. So this is the issue which we have analyzed after going through the conversations regarding these different problems faced by the farmers for the Kisan call center data set. Then there were the questions related to like best practices that can help increase yield in terms of quantity or quality of potato crop, and even further other crops as well. So if you take an example of potato here, common question were like, what height should I put water? How many days? After how many days should I harvest? So, depending on crop to crop, how much water, how much fertilizers, how much these things have to be done, what is to be done in order to get a good yield out of it. So, questions like that, Then, if you talk about the unbiased recommendations on the product, so farmer wanted the recommendations from agri experts on products they should purchase. So when they went to a local vendor, they are having a lot of choices of seeds and everything. So they are not aware of everything. So they somehow have to rely upon what the local vendor is saying. So local vendor will gonna always thinking of its own, from where it's getting more margin, he will want to be recommending that part. So there is a lack of knowledge, there's a lack of understanding like what's going on, what seed is best, whatever the scientists are doing, whatever they are preparing, they're making for them the good quality seeds. How should the farmer should get knowledgeable about that, because he's facing issues to get information about what's being new released in the market. So there's no one to recommend that part to them. So that's the problem which we have seen. So by keeping all these things in mind, we are building the knowledge base for our bot so that we can cover all these aspects as much as possible. Now we will have a glimpse of what happened due to the lack of knowledge. So we are working on a 400-acre lands of farmland beside the Chatbir Zoo, and it's near Zirakpur. The farmer working there entails his fertilizer knowledge by assuming it will generate the good yield, which will ultimately raise his earnings while lowering the risk. Because he did not have access to the soil testing and everything, only he was having a limited access to the agronomy. So he naively applied the fertilizers onto his field by like thinking, okay, if I will provide something in more amount, it might grow a bit more and I will gonna have a good yield out of it. But as I have already been said this thing many times, the local vendors are unbiased towards the farmer. So one of the local vendor told him to do so as well. but because before doing anything, if he wants to apply fertilizer, generally when a person visits a market or a shop, we can have a word. We generally have a word with the person like, okay, I'm going to do this. Will it be good or no? Like having a like bit advice of that. So that holds some amount of impression on the person. So that's what happened here. Once one of the local vendor told him to do that, and then he asked the colleague also who was following the same profession, his fellow mate who's having a farm, and besides that, he also said like, okay, it will be good. You should use excess fertilizer. It will enhance productivity. So see, the lack of knowledge has done what he was opined that applying excess fertilizer would increase his production. However, by uncritically following their advice, his crop was damaged due to over fertilization. And we all know like over fertilizer can actually decrease the growth of a plant as well as leave the plants weak and vulnerable to pest and diseases. But he was not aware of that knowledge, so he blindly followed them to his limited knowledge, to the advice of fellow mate, to the advice of vendor. He took that decision, and in result, his crop got affected. Applying too much fertilizer is not only reducing the yield but also affecting the environment and actually the complete food chain, because ultimately we are the human beings which will gonna be consuming that crop. So a lack of knowledge is a very big issue. So if it means that also like if the farmer is knowledgeable about what he has to do, then a lot of problems can be solved, because he will, if he is knowing, okay, so this thing to be done for this crop, and if something like that is happened, if he will be taking a good appropriate measures and having a good yield out of it, ultimately he will be happy, and the whole food chain of what we can say food cycle, they will gonna work in a proper appropriate manner. So our ultimate aim is like we are not saying like farmers shouldn't be using the fertilizers or doing that, not using these insecticides. So and the farming is not possible without that. Uh, I will not say possible, but yeah, good farming. Our ultimate aim will be like we are building a board by keeping this thing in mind that it should be easily accessible. Firstly, easy to operate, very straightforward, and yet very powerful to understand what the farmer trying to say us. So it shouldn't be like confined to something and farmer is having a limited access. Okay, if I want to ask something specific, only then I can use this bot. It should be like a friend to a farmer to whom he can talk about anything or anything about the domain. We don't want that farmer should get misguided. Rather, he should be knowledgeable about what to do when with the help of assistant. So he can take advices, he can take the opinion, he can talk to bot, he can talk about the problems he is facing, he can talk about whatever the advice or whatever the support he needs from someone, or we can say the expert. So we encourage them to use fertilizers whenever there is a need to do so by consulting with the bot or by with the domain experts. That's their choice, to whom they want to expert. But yeah, if bot, most of the cases bot will be able to answer. But if somehow there is something which is appearing like which is not being present in the knowledge base of a bot, because this kind of situation can happen. So at that point of time, we can connect them to the domain experts. A live chat can be initiated with the domain experts. So this will help them to like go to the root cause of the problem and have a solution for it for sure. So they don't have to move here and there. So there will be one step solution for everything. And he must be able to get assistance and find a suitable solution to get rid of the diseases and would be able to generate good yield ultimately. And if we talk about how far we have come, so we, as I've been already saying the same thing in the previous slide as well, we have started exploring with the different types of crops from the Kisan call center data. After exploring, we saw like a wheat crop is one dominating the other crops. So we proceed with the wheat, then with the paddy crop, then we move towards the chili crop farming, and then pea crop is the one which is going on right now. And if we talk about the aspects which we have covered, the query types, so that will be majorly covering each and everything that has been present in KCC dataset, except the weather queries, because any query related to weather will be directly right away answered by the weather forecasting API. So that part is not being picked up by us from the KCC dataset. Apart from that, anything related to weed, disease, insects, like you can say any support or any query, everything is being covered. For English language, we have covered all 4 of them, the crops which I mentioned above, wheat, paddy, chili, and pea crop. But for the Punjabi, we have covered 2 so far, and we are taking help of Trust Agriculture as well to have the answers for a few questions which are not being present, or which we can say which we are having a doubt about. So that's we are very thankful to them for that as well. And for the Hindi language, the work is being started for the wheat crop, but yeah, it's an ongoing process. So it's not being in, we can say, is ready for us right now, but it's in progress. So and that's about the current status of what we are doing. And if I talk about the future scope of what we are planning to achieve in coming days and in future. So firstly, what we will gonna do is we will gonna have a bot ready for 5 to 6 crops. We will gonna release it for the farmers. They will use it. They will gonna be providing us the feedback, how they are feeling with the interface, how they are feeling with the amount of query handling by the bot, how bot is responding to the queries, how friendly they are feeling with that. So after having all that sort of feedback, we will do some modifications as well. And in side by side, we will be adding more and more crops. Right now, our bot is being getting integrated with the mobile application. Very super soon, it will be released for the farmers so that they can utilize, and we can analyze the conversation they are having with the bot, so that we can continuously improve that. So in future, if I will talk, so in future, we will want that the farmer is not only having the technical support using the chatbot, but also the mental support as well. So it's a very major issue. We saw like so if the yield is not good, farmer is taking loans, and after he is not able to repay them, they got stressed about that. They are committing suicides, and all these kind of things are happening. So as we all know, villages are short in both, like villages have a shortage of psychiatrists and psychologists. So as a result, they are having no one to whom they may turn in most of the cases. So they are unaware of their mental illness, or we can say depression in many cases. And what we will be doing is once that part is being released in the production, they will be having conversation with the bot. We will be analyzing that conversation, basically doing the sentiment analysis on the textual data, and will be basically we are building as a separate project in the Sabud, the depression detection part. We will incorporate that part into this, and we will provide you can say alert to the farmer, alert to the farmer's family, where it will be showing like how much farmer is getting stressed about whatever the problem he is facing. So in that way, if it's increasing certain threshold, we can take care of that farmer, and we can stop these suicidal cases. So yeah, that is the future scope which we are trying to heading towards. Well, thank you so much. Now I'm open for the questions. You may ask me the questions if you are having it.
Thank you so much, sir. So now I'll be asking the questions.
Yes, sure.
Yes, sir. So the first question is there any subscription fee or for using this app, or is it free of cost?
No, it will be free of cost.
Okay, sir.
Yes.
So the second question is, do you provide any trainings to the farmer or any awareness program on how to use the app?
Yes, once the application will be ready, because there will be different other components as well, like I have discussed in what we are covering in Circulated Punjab project. So regarding those, we might provide them some initial training if they want to do insect detection, or if they want to see like what's problem occurring in their crop. So how to use that application. So initial workshops will be there.
Okay, sir. So the third question is, many of times it happens that multiple diseases have similar symptoms. So
Yes.
Is there any filter or sorting mechanism to find out the actual disease?
So yes, we will try to understand what farmer is trying to say. If the bot is not confident about what farmer is saying, he will gonna ask trailing questions, which will be more concerned towards the different crops. Let's suppose if it's getting confused between 2-3 crops, it will gonna provide the buttons where he can say, okay, the farmer can select the one among them, and then he can accordingly respond to that farmer.
Yes, sir. So the fourth question is, what are the different wireless modules to have sensor data from autonomous robotic systems that are being used in agriculture field applications?
So that will be more concerned with the IoT guys, because I'm concerned with the chatbot building part. So the sensor data and everything that could be better answered by them.
So the fifth question is, what are the social constraints on mass scale utilization of this app?
Can you please repeat that?
So what are the social constraints on mass scale utilization of these apps?
I don't think so. There will be any social constraint, because ultimately it will going to help a farmer. It will be acting like a friend to a farmer, to whom they can interact, to whom they can talk. Because as I've said, the future scope is to analyze what kind of or what farmer is trying to interact with the bot, so that we can understand the mental state of the farmer, and we could provide any solution to him. Any kind of support.
So the next question is, as you can see, the large proportion of farmers are switching their careers from farming sector every year. So do you think that IoT, AI, and agri apps will be a hope for them for not giving up on farming?
Yes, definitely, because when someone is making fooled by someone, like I'm saying, local vendors, and due to the lack of knowledge, the farmers are getting frustrated and they are losing faith in the agriculture, we can say, to some extent, not completely, but to some extent. But with the advancement of technology and with the help of all these uh, uh, ventures which we are doing for them, when they will be inculcating them into the routine, when they will imbibe them into their daily routine, then they will basically be able to have a support system around that. So that will motivate them to stay in this field and have a good deal out of whatever they are doing.
So the next question is, what are the risks associated with the adoption of these apps and farming system?
So I don't think so. There will be a risk of adopting these apps, because ultimately they are being made for their well-beingness. So according to me, there won't be a risk around that.
And so the last question is, the role of social media in effective utilization of these mobile apps in agriculture.
Yes, so social media plays a very crucial role. So as if you can look at each and I will not say each and every farmer, but most of the farmers are utilizing Facebook. So Facebook is so common among everyone nowadays, generally to the villages, as I will say basically nowadays, because the modern people are not modern, or we can say the ones which are moved to the cities, they are not much utilizing it. But the ones which are living in the villages or in these uh, undeveloped, we can say, areas, they are very much keen towards what's happening on the Facebook. So social media can play a very crucial role to educate them, to make them aware about these ongoing ventures and new technology which are coming up.
Okay, sir, thank you so much, sir. It was really a privilege having you here. And thank you so much for sharing your information and knowledge on Rasa and AgriBot as well. Thank you so much, sir.
Thank you so much for giving me the opportunity. I really enjoyed the session. Thank you.
Thank you, sir. Now for the session 2 of today, I would like to call upon Dr. Utkarsha. Over to you, ma'am. Everyone, the second session will begin shortly.
Thank you, Ms. Ishani. A very good evening, ladies and gentlemen. Myself, Ruchika Chaudhary, and I am currently pursuing my master's in agronomy. It is indeed my great pleasure and foremost duty to welcome you all to this program, embellished by the presence of dignitaries and respected personalities. I would utilize this opportunity to cordially welcome you all to this 21-day international training come workshop program on Agriculture 3.0. Our previous host has very beautifully explained the importance of agriculture in our lives, and therefore, it is the need of our to develop and learn such technologies which are smart, sustainable, and innovative in order to realize the dream of a new and strengthened India, of which agriculture is the backbone. This program has been organized jointly by Just Agriculture Magazine and Agro Environmental Education and Farmers Welfare Society. These both are currently the largest networks of agriculture and allied sector professionals in the country. The magazine has a readership of more than 1.05 lakh in India, which makes it a credible platform for researchers, students, and scientists to share their ideas on latest innovative topics. While the society, on the other hand, aims at enhancing livelihood opportunities for more than 1 million farm households in the country. Now, taking the program to the next segment of the session, I would like to invite our next speaker, Mr. Shailendra Singh, co-founder at Yuktix Technologies Private Limited, to deliver his lecture on agri-intelligence using IoT and AI. He has completed BTech in Electronics and Communication Engineering and have more than 5 years of experience in working in tech-driven agriculture field. He has deployed tech solutions for PepsiCo, ITC, CSA, and many other companies. His area of interest in agriculture is agri-tech, IoT, digital farms, weather forecast, precision farming, irrigation, and climate-smart agriculture. Sir, you are truly a gem, and it's a privilege to have you here and getting to listen to you. Please, sir, over to you.
Ruchika, sir is joining in a while. Sir is
Okay,
joining
sir.
in a short while. Just wait.
In the meantime, I would like you people to know about what is Just Agriculture. Just Agriculture is an open access, peer-reviewed e-magazine and new e-newsletter which started publishing from August 2020. And the magazine provides a platform to all the researchers, students, scholars, and scientists to share their ideas about their latest innovative topics. The aim of Just Agriculture magazine is to publish about latest innovations and upcoming experimental technologies to be adopted globally in the field of agriculture and allied sciences. This would help in disseminating scientific information and latest findings about the scientific community related to agriculture all over the globe. It is also connecting agriculturists from different domains of specialization and from the different regions across the globe and bringing them to a common platform which helps in disseminating the knowledge to the readers. And it is also actively involved in conducting trainings, seminars, and international conferences. So it's a next level approach towards agriculture development, and it's a
Ruchika sir
contribution.
is joined. Can you again introduce him?
Good evening, sir.
Hello.
Our next speaker is Mr. Shailendra Singh, co-founder at Yuktix Technologies Private Limited. And I invite him to deliver his lecture on agri-intelligence using IoT and AI. He has completed BTech in Electronics and Communication Engineering and have more than 5 years experience of working in tech-driven agriculture. He has deployed tech solutions for PepsiCo, ITC, CSA, and many other companies. His area of interest in agriculture is agri-tech, IoT, digital farms, weather forecast, precision farming, irrigation, and climate-smart agriculture. Sir, you are truly a gem, and it's a privilege to have you here and getting to listen to you. Please, sir, over to you.
Yeah, thanks, Ruchika. First of all, thanks for providing me the opportunity to come in front of all these people who are participating in today's webinar. And I think I have 1 hour, so I'll be quick around the topic of IoT and AI. And my main target would be to be focusing more on the application side, because if we will start having deep dive in technology, it will need a lot of time. I hope everybody is able to see my screen and I'm audible to all of you. Can I go ahead?
Yes, sir.
Yeah, thank you. So I'm Shailendra. I'm co-founder at Yuktix Technologies. Yuktix is a agri-tech startup. We are based out in Bangalore, and we are developing next generation agri-intelligence tool for crop management, which uses the power of IoT and AI. IoT as an Internet of Things, and AI as an artificial intelligence that work on top of data collected by the IoT devices. So going to the next slide. These are some of the components that any agri-tech startup would do, and specifically any of the startup who are in the field of IoT, they deal around these many things, as in capturing of meso and micro weather at the farm level. Some of the startup, for example, we also have these solar powered cameras that capture the photo of the growth of the plant to figure out if the plant is going through any biotic or abiotic stress. We provide irrigation advisory, or any other startup in the field of IoT anywhere in the world. This will be definitely one of the output, that irrigation advisory data that we are collecting is for agronomists also, disease and pest forecast, NDVI or satellite imaging, summary and report, and multiple things. So this is just to give you a gist of what agri-tech startup do in the field of agriculture. So this is how technology work, and in my next slide, I will deep dive into individual component of the IoT. We capture the physical variables from the field. These physical variables can be from the IoT devices, starting from temperature, humidity, pressure, rainfall, wind speed, wind direction, solar radiation, leaf wetness, soil moisture, soil EC, soil temperature, water level, and lugs, and I think few other variables, which means some people even talk about NPK, but those sensors are not very much reliable. The physical variables can be captured from the satellite also, as in the photo of a specific farm, how the plant growth is happening. The physical variable can also be captured from the solar powered cameras, and there are multiple open source APIs which provide you district level or block level weather forecast. You collect all this information, you get to a cloud where you manage all this data that is called IoT data in time series database or normal DB. User is in normal DB and all this IoT data, because that is very high frequency data that you store into a time series database. Then you process this data as per the crop requirement. For example, when you are running any kind of disease forecasting model for apple, you will need a couple of variables, for example, temperature, humidity, and leaf wetness. So you have a crop expertise, you have data capture from the field, you club them together, you analyze them, and you provide some actionable output to the user. Now, the output can be in different terms. The output can be delivered to the user over the application, over the web dashboard, or over the SMS also. In some cases, we are delivering the output to the user in over the SMS because they don't have the multimedia phone with them. Not all of them, but some of them don't have the multimedia phone. So this is what we do in Yuktix. Now, coming to what we call as smart farming, there are multiple components starting from image analysis, image which is captured from satellite or drone or camera. Other component is Internet of Things, in which we are going to deep dive. Few other components are soil analytics. There are a couple of startups which are working in the field of soil analytics, who are providing real-time, not real-time, but yeah, very much real-time soil analysis for micro and macronutrients. Blockchain is for traceability from where the some produce has been originated, what are the steps where it is stopped, and if I am the end user, I can scan a barcode, I can see, okay, this produce is from so and so farmer, and this much time it has taken to reach to me. And then the last data, basically artificial intelligence and machine learning on data, big data, data analytics, and again similar kind of thing like farm management software, ERP application. So all this come together under the smart farming, or what people or what is called as precision farming. Going to the next slide. Okay, so so far, how we are going to have this session means, are we going to have open kind of session where people will ask question, or we'll have the question in the last, or should I go purely through this deck of slides?
So we would be having the questions at the last of the session.
Okay, fine. So after this is the complete picture of precision farming. I am going to focus more on the IoT part and the data analytics part. So when we talk about the IoT, means most of the people ask, okay, what IoT is? So IoT is Internet of Things. Things can be these sensors. Things can be physical variables. So you connect those physical variables to the internet, they become Internet of Things. And what are the major components of any Internet of Things devices or any Internet of Things? So the three major components of Internet of Things are the sensor, these sensor which I mentioned in the starting. Again, people ask a question about, okay, what can be measured? So not all parameters can be measured. Yes, there are multiple parameters that can be measured. Second question is, okay, what is required and what is economical? You can in fact measure how the stem is growing, what is the size of the stem at every stage of the crop, right? You can figure out what is the leaf temperature also. But when it comes to economical thing, making it available to a real farmer, are they even required? How much part they play? Are they required for the researcher, or are they required for the common normal farmer? So sensor varies from temperature, humidity, pressure, rainfall, wind speed, wind direction. Then leaf wetness is definitely one sensor that is very much useful when you are doing any kind of work around the fungal diseases, for example, pouty mildew or downy mildew. Then soil moisture. There are different kind of soil moisture sensor available in the market. Some are resistance based, some are tension based, some are simply a gypsum block, some are electrical conductivity based, some are capacitance based, right? So they are different kind of soil moisture sensor, and they provide different kind of output also. For example, a tensiometer provide the output in terms of pressure. Volumetric water content sensor provide output in terms of percentage of moisture in the soil. Apart from that, there are few sensors which are costly, but they can also provide you the electrical conductivity. How much, what is the percentage of ions present in the soil, using which you can figure out when the fertigation has been done. Soil temperature is also a sensor which is used to figure out when to irrigate. When to irrigate very less, means there was a recent case with one of the farmer that we have, that he has sufficient soil moisture at 10 centimeter depth and 30 centimeter depth. But superficially, there was no soil moisture because of the extreme heat. And so this is where soil temperature is required. So you can integrate soil temperature in the irrigation advisory. So there are different sensors that are possible. There are few Chinese sensors available for NPK also. pH also you can measure, but again, these variables are not very much important in continuous monitoring, because NPK will not vary on daily basis, or pH will not vary on daily basis. So the first component of any IoT ecosystem is the sensor, agriculture sensor. Those are micro weather and soil sensor. The second component is the device. So sensor itself cannot do anything. You need to have a device that can monitor, that can measure the variables, that can measure the values for the sensor, can put it in a human readable format, because sensors are either digital or analog. So they either provide you some bits in 0 1 0 1 0 1 that we as a human being cannot understand, or either they provide output in terms of voltage. The voltage can vary from 0 to 5 volt or 0 to 3 volt. So you cannot understand what sensor is providing as output. You need to have a hardware device which can manipulate, which can understand the reading from sensor, convert it into a human readable format, and then push it to the cloud through some communication option, right? IoT devices for micro weather, smart irrigation, insect counting, and field view camera. So first part of the IoT ecosystem was sensor. Second part is the hardware. Third part, which I have not mentioned, probably it will be here. So these are the devices, and the third part is, so first part is sensor, second part is devices, third part is any web dashboard or cloud platform where you will put all these variables in front of the user. So again, we will go deep inside all these three components. So what is IoT? So as I mentioned, the first part was definitely sensors. I discuss about sensor. I discuss about hardware. So hardware is something physical in which you integrate sensor. So I will show you the pictures of the hardware also, so that you can understand that what actually the hardware means. So you have sensors, you integrate them to a hardware, then you write some code inside the hardware, and which help you to read the sensor values. Then you have a communication option using which you transfer these values from the device in the field to a cloud. For example, your phone is there, right? Your phone has sensors. Now your phone is the hardware, and the Android OS inside this is the firmware. So you have sensors, you have hardware, the Android OS is the firmware. The Android OS read the GPS coordinates from this device, it's sent to the cloud. And this is how Uber or any other taxi drivers or any other company is able to locate where you are. So GPS is a sensor in the case of phone. GPS is a sensor. Your phone physical chipset inside this is the hardware. The Android OS is the firmware. The communication is either through Wi-Fi or through GPRS 4G module inside this. So this can be termed as IoT device. If you put this thing somewhere outside, you open the camera and you developed an application which can keep on taking photo continuously, this is IoT device. So now the second part is the IoT cloud. So okay, you have collected all this data. Now what means how you will put it in front of the user. You need to store it somewhere. For example, when you read, you always write something on the copy. So your copy can be, you can compare your copy as a cloud kind of thing. So in this case, IoT cloud is a server hosted somewhere on the internet to which you are sending all this device data for the management. So you can have hundreds of thousands of devices. You need to manage those devices. You need to manage those devices data also. You need to assign those devices to some user. So this all thing happen on the IoT cloud. So you have time series database, you have normal database, you have worker management. There are multiple processing happening over there. So now you have all this data collected onto the IoT the cloud. Now you need to have an API machine. API machine is more like something that will collect data from IoT device. It will analyze something and it will again expose that analysis to be presented in front of user. So one more component is computation. So you can think of computation as a mathematical equation. X is equal to means y is equal to x plus v. X is the variable and then v is some kind of y. So this kind of equations, I think anybody who is from agriculture field and who is working on development of some new model, they will understand linear equations or regression equations. Then you can have different kind of reporting. For example, you want to send an email report to 100 users what is happening in their field. Now other thing can be you want to alert some user, okay, there's rain happening in your field if you want to take some action. So all this computation happen in the backend server, but we have divided this into three part: IoT cloud management part, the API machine, the computation. And then after all this, you need to present it in front of the user. That presentation can happen via web dashboard, via smartphone application. So as I was talking earlier, this is the hardware. You can see on the top left-hand corner, these are the IoT devices, right? You can see the battery casing. If you can see properly, there's a chip inside that, what we call as microcontroller. So these are the hardware that we manufacture. The process of developing this hardware has multiple steps, starting from the schematic design to the Gerber file to the printing of this PCB, which don't have any component. The component come to our office. We assemble these components onto the PCB, right? Then we put the code. So after, on the right hand side, top hand corner, you can see that you put this PCB inside the enclosure, you put the connector. Then downside, bottom left hand side, you can see people working on the hardware. Means they're putting the software in this hardware. And then right hand side bottom, you can see how the packed devices look like. So this is how the hardware look like. This is how the boxes look like. This is the kind of steps that we take to develop any kind of IoT device. So this is I have talked about different components of IoT, starting from sensor to hardware to firmware to communication option. Then IoT cloud, what you do in IoT cloud, you manage these devices, you manage these devices data, then you have API machine, you do a lot of computation, you have reporting, alert, and then you present it to the user. So now, and this is more like, okay, how does the actual hardware look like? What is the process over here? If somebody have any question, they can write it down. I can answer them in the last, or if the team wanted to share my WhatsApp number, they can share it, and you can ask me any specific question on technical side. I'm not going to discuss too much on this, because again, this can be a long loop, very long loop. So these are some of the applications that IoT application in agriculture. So usually, just like we always divide agriculture into two parts: pre-harvest and post-harvest. So pre-harvest, you have different application like irrigation, disease and pest management, soil management, weather forecast, image analysis, image scouting, asset tracing. Post-harvest, you have hydroponics, aquaponics, vertical, livestock, dairy, farm machinery. So these are some of the applications that at least I can think of, and we'll go on in each of the application in the next slides. So this is more like a smart farm. So IoT in the pre-harvest. So I will take some time to explain what is being represented in this presentation. So you can see here, there are few sensors which are deployed. These sensors are all solar powered. They are all wireless. They come with different sensors like soil moisture, lux, air temperature and humidity. There's another sensor which comes with only soil moisture and soil temperature. There is one more sensor that comes with only soil moisture. So these all sensors are deployed in the field. They communicate to a gateway. So they all are wireless sensors. They are communicating to a gateway, or you can call it as a weather station with different sensors. So this can be a gateway. This can have sensors like rainfall, leaf wetness, air temperature, air humidity, solar radiation. So all these small sensor node communicate to a gateway. There can be a weather station. These sensor node communicate to the gateway using sub-gigahertz communication. That is an open source ISM band. You might have heard of LoRa, you might have heard of Zigbee, or you might have heard of different other wireless communication providers. I think I'm forgetting there are a couple of more names. These days, there are also low Earth orbit satellites which allow you to communicate data to satellite. So here we are using sub-gigahertz communication. These net communicate to a gateway. This gateway communicate to the cloud using GPRS communication or sub-gigahertz or satellite communication or even Wi-Fi. On the cloud, you process all this information and then you present this information in front of the user using web dashboard or Android application. And this actionable output can be irrigation control or irrigation advisory. As in, you can control the irrigation automatically, or you can advise farmer when to irrigate or how much time to irrigate in terms of liter per plant, or in terms of minutes of motor in turn on stage. The second output can be disease and pest prediction. So you can analyze this information. If that is suitable for any disease to happen, you can provide early warning to the growers. Weather prediction is definitely possible using AI and ML methods. Real-time weather information, yes, you are capturing all this information You are telling the farmer, is it too hot? Is it too cold? What is the current temperature over there? And then hot spot detection. This hot spot detection is usually through the drones or through the satellite. So this is how a smart farm look like. There are multiple other components of smart farm that I'm not capturing because I'm more like focusing on the pre-harvest and on the IoT side. So moving ahead, so this is one small video that we have. You can go on to the Yutik's YouTube channel and you can look at other videos. So I will not. I'll move on to the next slide instead of focusing on this video. Yeah. So I think I talked about the a kind of smart farm where multiple sensors are deployed. I will come down to the other applications like smart irrigation. So a smart irrigation, you can have a smart irrigation in different formats. For example, they can be local control, right? So you can modulate the amount of water you are providing in any field in different ways. Either you can have local control or you can have remote control. When I talk about local control, it can be based upon flow, the amount of water that has flown through a flow meter, or it can be based upon the sensor. Means you can put a sensor in the soil, you can measure, okay, what is the current soil moisture, and you can turn off or turn on the motor based upon the sensor values. Or you can have timer based. Okay, you know that you have to irrigate daily for half an hour. You can turn on a timer. The timer will keep on counting for 30 minutes. After 30 minutes, it will turn off the motor. Right. So you can have local control. This flow-based control, I was talking to a professor in ICAR Bangalore, and they in fact say that, okay, I know that on a daily basis, starting from the day of transplantation, on daily basis, how much water is required. Somebody has raised a hand, so as the team has suggested, please have your question ready in the last. You can answer. I can answer your question in the last. Team, can I go ahead, or you want to let others ask question? I think I'll go ahead. And this is more like a local control. The other thing is remote control. So how you can control any motor remotely. People would have a lot of questions over here. What if there's no power, or if the power is there? So yes, there are few considerations. Whenever you are developing any kind of system, you need to start with some consideration that power is there. That definitely power is there. There's no power. You need to have a backup system that will, suppose you have to turn on a motor, and in the middle the power goes. So you need to have a system that can store, okay, for how much time that motor was turned on, and as soon as power come back, you need to again start on the same location. So I have discussed about the local control. Local control can be done based upon amount of water flowing through a flow meter. You keep on calculating how much water has flowed. Okay, if you have to irrigate 100 liters of water in a 1 acre area, you measure, okay, 100 liters has flown through the flow meter. You turn on the motor, and everywhere you will need an IoT device that can sense from the flow meter, or that can take input from the sensor, or that can sense from the RTC. RTC is a real-time clock. So these are some ways of local control. Remote control can be based upon internet. They can be based upon SMS. I think IVR and DTMF are both same. So remote control can be done based upon internet. I will cite one example over here. We are doing a project in UP. There, the requirement is that you need to have a system which can control the irrigation based upon the crop stage, based upon the weather forecast, and you also need to provide an option where the user can control the irrigation remotely. So these are the kind of this is totally internet based. If user want to control the irrigation remotely, he want to turn off the motor and then he want to turn on a solenoid valve, then you need to provide an internet connectivity. Internet connectivity need to be strong. There should be no, means it need to be stable enough, right? So, and the system should be able to get data from the server about the weather forecast. That is it going to rain next 2 or 3 days. Then there are some algorithm which can take weather forecast as an input, which will take the crop growth stage as an input, which will take the soil moisture as an input, and it will also see if the user has asked to turn on the motor, turn on the motor. So the algorithm will combine all this value, and then based upon the output, the motor will be turned down and the solenoid valve will be turned down. As much based, there are multiple companies. You can search about Kisan Raja. I think there are hundreds of companies. which provide this SMS-based or IVR or DTMF-based irrigation control. There are hundreds of companies. Simply search for SMS-based irrigation controller or phone call-based irrigation controller. One example I gave you about the Kisan Raja. They are very well known. They Vijay Bhaskar Dinapur is working in the field for the last almost like 10 to 12 years. So you can simply search. They are also a company based out in Bangalore. So I will go to the next slide. This is more like an illustration of how the smart irrigation or smart irrigation work. So you can see these are 4 plots: plot 1, plot 2, plot 3, plot 4. The communication between the sensor to the receiver can be either wired or wireless. You can have a RS485 based wired communication from individual sensor to a receiver, or you can have sub-gigahertz based communication from individual sensor to the receiver. So that communication can be anything. It can be wired, it can be wireless. So this is solar powered. The sensor goes inside the field. You monitor the soil moisture from this plot 1. You send data from this sensor to the sensor data receiver based upon whatever settings has been done. This is a receiver based upon whatever settings has been done on the gateway. For example, if you set that whenever the soil moisture is less than 20%, you turn on the motor. So this gateway will turn on the S1 valve. Now S1 is solenoid valve 1. Now solenoid valve 1 control the water flowing in the plot 1. Similarly, S2 will control the water flowing in the plot 2. S3 will control the water flowing into plot 3. S4 will control the water flowing into plot 4. So based upon the sensor values sent from individual sensor deployed in a specific plot, you will control the this gateway will control the motor and then turn on or turn off the individual solenoid valve. That will again irrigate into a specific field. So you can have hundreds of plots, you can have hundreds of sensors. There, people might ask you question that, okay, how do you define that? How many sensors are required in a specific plot? So there are specific considerations for finalizing how many sensors are required in an individual plot. And these considerations are if the plot is plain, if the soil is if there is no change in the if the plot is plain, there is no inclination or declination of the plot. So again, all these values are coming to the receiver, then going to the gateway. You can transfer these values from gateway to the cloud using 4G communication, and you can have an option over here using which you can in fact control that, okay, you need to turn on the valve on this specific day. So again, this is just a sample schematic to tell you how the smart irrigation can work in the field. I hope I'm not going too fast because we have limited time over here and I still have almost like 10 12 slides left in this presentation. So I want to cover most of the slides so you can get the maximum out of this presentation. This I would like to show you. Let me see if I can run this video here or not. I cannot run this video over here. This is a video of how we have deployed this smart irrigation in the tomato field in Kuppam. So this is, if you can see, this is more like a wireless sensor, which come with temperature, humidity, pressure, and the soil sensor goes inside the soil. This is a tomato field with the mulching in place. So people were not able to figure out how the soil moisture, what is the amount of soil moisture even visually inside this mulch. So this was one of the video. I think I'm not able to play this video. Let's go to the other slide. Let me go into the full screen mode. This is one example of the post-harvest inside the cold storage. So wherever you want to monitor what is happening inside the cold storage, or wherever you are storing produce, or in cases when you are transferring the produce or any kind of seed from the research lab to a cold storage or to the field, everybody want to understand what is happening because of the temperature, the produce quality can matter, can vary, right? So you always wanted to make sure that anything that whose quality can be affected is in a temperature controlled environment. And how you can monitor that? You need to put IoT devices inside those crates, or inside those silos, or inside those deep freezers, or inside those cold storage, or warehouses. The same thing, that you have wireless devices. Why wireless? It can be wired also, but most of the people these days prefer wireless, right? So you can have these devices which are wireless. These devices need to be battery powered. They can be long range. So if anyone of you has gone inside a cold storage in India, there are different kind of cold storage. Some are vertically divided into the different floors. Some are vertically divided into the different rooms, or some are horizontally divided into different floors, right? So you need to have these small devices that you can deploy, which are battery powered, which can come. And if you have multiple devices deployed inside a cold storage, they need to be wireless, and they need to the data from them need to come out of the cold storage. So that's why I've written long range. So outside, so you have these devices inside deep freezer, inside the shipping container, inside the refrigerated trucks, inside the silos, or inside a cold storage warehouse. You can have different kind of communication option like GPRS, Wi-Fi, even Ethernet, or sub-gigahertz. In the moving truck, you can have either GPRS based or satellite based. So you have different communication option. You have sensor. Data from them come to your central cloud. You generate different kind of reports, alert, compression, data download. You present this information in front of the user. Now, a user can utilize this information in multiple ways. They can either generate a report, share with their management. They can figure out what if some of the warehouse is not maintaining the temperature which is required to be maintained. You can alert them, okay, that why you're not turning on to chiller. So there are multiple use cases of this of these IoT devices deployed inside the cold storage. Going further, again, this was for another video. I don't know why I'm not able to run these videos. Let me see if I, guys, let me check if I can figure out this on the YouTube channel, because I hope, just a moment, just give me a moment. I hope now my screen will be visible to every one of you, the full screen. Let me go. So this was the video that is for the cold storage. This will give you a real sense, okay, how the screen means how the actual device look like. Just a moment. So this is a device. You can see it's the wireless device. It's a battery powered device. Sensor is inside this. This is a real cold storage. You can see one device over here. This is more like horizontally divided. So one here. This is, yeah, you can see one here. You can see one here. One here. There are different floors. There are different locations inside. I think this was a chili warehouse. And then you come out where there's a gateway. So all these are wireless devices. They are communicating to a gateway. Let me check if the gateway is presented here or not. Team, who is this? I can either stop the presentation or probably can go out of this meeting. Anyone here? Ruchika?
Yes, sir.
Have you seen what is happening here?
Yes, sir.
So either you can ask them, if somebody is not interested in the webinar, they can leave, or they can start doing this bullshit over here.
So sorry for the inconvenience. We'll deal
This is
with
not
it.
this is not inconvenient. This is utter bullshit.
Yes, sir.
Either you have people who are really interested, or you should not invite these people. Okay, anyway,
Sorry, sir.
means I will simply go ahead. If somebody is not interested, they can simply leave the webinar. I will show you a couple of others. I think this is again this is the work that we have done for the. This was more like a wireless sensor that we have deployed for the cotton field for the irrigation control. You can see this is a wireless sensor. This is in Kuppam. This was a cotton field. This is a wireless sensor. This comes with a soil moisture. This communicate back to a gateway which was deployed almost like 1 kilometer away from this location. Let me see if I have. Yeah, you can. This is another sensor. I think I don't have the other gateway thing over here, but this is how some of the sensor deployment in real field look like. I'll go back to the presentation. Here, this is another example of IoT deployment, which is used to monitor the asset monitoring, which is using GPS. So this is used to monitor where the assets are. Assets can be different trailers, different tractors, threshers, or some other useful, or even pivot, or means anything, any machinery that is used in a farm. Why this is utilized? Because the management or the owner want to know, are the assets in real use or not, or they want to monitor what is the amount of fuel in each of these assets. The assets can be tractor, threshers, power tillers, truck for transport of agriculture produce. So asset monitoring is definitely one important application of IoT in agriculture that can be during the pre-harvest, or that can be during the post-harvest. This was some work that we were doing for Northeast, one of the Northeast state, in which they wanted to monitor the GPS location of individual assets. They want to monitor the fuel level of the inside of their individual asset. They want to identify which driver is using a specific asset, and they also want to analyze what is the machine health. Is somebody driving the asset too fast, or or through a very odd terrain, right? So all this information, again, they are different sensor. If you want to monitor the location, this is more like a GPS GPS sensor. You can use fuel level gauges are there. Driver identification can happen through RFID card. You can have a RFID reader. Somebody put the RFID card. You match the RFID number to a database and figure out who is driving that specific asset. And machine health can be monitored using vibration sensors. So you monitor all this variable, you put them to the cloud, and then you provide a different output to the user. The output can be used to figure out real-time tracking, the fuel level, the occupancy of machine, different kind of reports. You can generate SMS, email as an alert. You can predict the availability of the machine. For example, if somebody is using a GPS for soil tilling, and right now that machine is driving at a X speed, and the area is almost like 20 hectare, 30 hectare, you can figure out how much time will the user will take to till the whole 20 hectare area, and based upon that you can figure out what will be the availability of this machine next day or today, so that you can optimize the use of the machines. This is one example of asset monitoring in agriculture. Hydroponics, again, IoT for hydroponics or vertical farming, similar kind of thing. Again, you have an IoT device. Now in all this application, one thing that is varying from application to application is a sensor. So not all sensors are required in every application. Based upon the specific vertical, based upon the specific application, sensor will keep on changing. For example, here fuel level sensors are there, RFID is there, GPS is there, vibration sensors are there. In hydroponics, temperature, humidity are very important. Lux is very important because you are doing this thing inside a productive thing. And then you need to have wind speed, water pH. If you are into hydroponics, water pH matters a lot because you want to maintain the water pH, CO2. So again, same thing. You have different sensors as per the application. You have IoT device. IoT device communicate to the cloud using different communication option. You analyze the data that you're collecting as per the crop. For example, if you have leafy vegetable, you would like to understand if there's any disease happening to them or not. And disease will be mostly the fungal diseases, right? So in order to predict these fungal diseases, you need to have a specific kind of sensors. And then again, once you analyze, you put it in front of user. Now you can put in front of users either on web dashboard or either on the smartphone application. So again, this is, I think I have gone through this in my first slides. Simple example how we have deployed it inside a greenhouse. Another example, another photo of our deployment inside a greenhouse. This was a capsicum, and this is very interesting. There means, in fact, we help this is specific user to avoid the cracking at the fruit. So cracking in any kind of fruit happen because of the continuous shrinking and expansion of the fruit, and that happen if the plant is not able to extract sufficient amount of water from the soil. And this was mostly a sandy soil, so they were irrigating on daily basis, but the soil was not able to hold the sufficient amount of water around the roots, and that's why berry cracking was happening. This is another example. We are recently doing this project in again in UP for the poultry farm. This is also one of the example of IoT application in agriculture, or you can say it's one of the verticals of agriculture. So there we have this wind speed wind direction sensor, we have cameras, we have ammonia sensor, we have CO2 sensor, because these are the variables which impact the poultry farm. You sense all this value, and then you control the exhaust fan, you control the heater, you control the sprinklers. All this information is again sent to the cloud and presented in front of the user. This is one more example of IoT application. Some of the devices that we have deployed in remote locations all across India. These are the key devices deployed in Odisha for an NGO, and they are with the rainfall sensor. The black sensor is the rainfall sensor. You can see it's a tipping bucket rainfall. The round color structure below the rainfall is the temperature and humidity sensor. This is a solar radiation shield. All the agriculture students will know about the estimation screen, right? So you put any sensor or thermometer inside the estimation screen because you want to monitor the air temperature and air humidity. This is the IoT box. This is a solar panel, and you can see a wire going down. This is a soil moisture sensor. Again, some more deployments of what we have done in different locations. This, I think I have shown you the video. This is a soil moisture sensor deployed in a cotton field, which is using drip irrigation to control the amount of soil moisture inside the soil. And another example, this is a banana field in Jalgaon area. So I think I have discussed about this point, at how many sensors are required per acre or per hectare. This is very complex question. It depends upon how granular you want to go. Our researcher will like to have more and more sensors, because his work is to collect as much data from the field that he can analyze, and he can develop a model which required even less sensors. So you can see there are different plots. In fact, you can physically see that there are different rows. So you can have one sensor in each row, and it also depends upon how you have done the irrigation planning. So similarly, you are collecting this information from the field, you are pushing it to the gateway that is controlling the solenoid valve and motor. At the same time, you are pushing all this information to the cloud also. Another example of the irrigation, this is the orange field. We are trying to work out. This is either orange or red. I'm not sure about it. I think this is an orange field. We are doing some work for the orange grower. So again, plot is specific. So you have different sensors deployed inside a specific plot. You sense this data, you send it to cloud, you run different kind of algorithm, and then you tell the grower that, okay, you should irrigate your field for this much amount of time, or you can even automate that. It depends upon the specific application. Some example of deployment in grape field, or inside the shade net, or inside a greenhouse. Yeah, this is the example of what I was trying to talk about, about the cotton. So you can see different devices deployed in different location in almost like 2-kilometer circle. All this information was coming to this gateway. You can see these two devices, and then you can see a receiver. So all these devices were wireless. They were communicating to a gateway. This is the receiver over here on the top side. Data from this goes to the gateway. Gateway send it back to the cloud. You also have a validation deployed over there. This we did in Kopam. So I think I am almost like done. I don't have, I think, sufficient time to talk about the end-to-end case study. Probably I'm open to the question over here. Team, you can open it to the open it for us to for the question. If anyone has any question, they can ask me right now, or probably we can conclude the session. And if anybody wants to ask any question, the team can share my email ID, and you can ask this question over the email also.
Thank you, sir, for this incredible session. It was informative from the and we have learned something new from you. And we'll be starting the question and answer round.
Sure.
Within few minutes. So first question is, what is the influence of IoT and artificial intelligence in smart agriculture system?
I will start from an example. So I was talking to somebody in Odisha, and he was an old farmer. He said that in the earlier days, people or their elders used to put thumb in their tongue, and they used to put a thumb outside. And they used to tell, is it going to rain tomorrow or not? Because the climate was not changing that much. These days, resources are not available that much. If you go to Coimbatore, people are moving from banana or coconut to the crops which consume less water. So IoT and AI play very important role in order to optimize a resource or in order to provide only that quantity of resource to the plant which is sufficient for their growth. If you, another example is if you irrigate more or if you irrigate less, it is going to impact the growth of the plant, right? So you need to provide them sufficient for their growth. And this is where IoT, sensors, and AI come into picture. That you are, this is more like a farming driven by data. Earlier it was most like guesswork, but right now it is driven by data. So this is how I think IoT and AI is impacting the farming at present.
Thank you, sir. So next question is, since large proportion of Indian farmers are marginal, do these IoT-based approaches are affordable to them?
They are very much affordable. It depends upon, look, I think I have been repeating this question, repeating this point during the webinar, that people ask how many number of sensors per acre or per 5 acre or per village, right? So advisories can be at different level. Advisory can be at the farm level also. Advisory can be at village level also. Advisory can be at block level. I think IMD is already doing advisory at block level. Or some companies are already doing advisory at block level. So it depends upon how much precise you want to go. So IoT and AI again is similar to a phone. Earlier, just 10 year, 12 year back, or in 2001, not many one of us has seen the mobile phone. Now even a risk, again, this might be a bad thing to say. I don't know whether it's a bad thing or not. Now these days, even a rickshaw wala has a smartphone. It depends upon the manufacturing quantity also. It depends upon quantity. It depends upon at what level you are implementing the IoT and AI. And are you going to a farm for providing advisory, or you are providing advisory at a village level?
So next question is, what is the use of false color code in remote sensing?
False color code, I am not sure. I am not expert in GIS. But yeah, false color, I know about the NDVI imaging. When you identify the plant which are healthier as green, which are impacted by orange, and then which are definitely impacted by the stress as red. False colors, I'm not sure. Probably a GIS expert can tell you more about that.
Okay, sir. Sir, what are the benefits of using agricultural sensors?
Just a moment. I think this whole webinar was behind this, that why we are using agriculture sensor in agriculture. So I have talked about the pre-harvest, I talked about the smart irrigation, I have talked about pest and disease forecasting, right? So everywhere you are using sensors.
And sir, what are the different uses of cloud in IoT?
Cloud is one of the most important part. So in our technical term, if you are not sending this data to the cloud, we call them as WSN, that is called wireless sensor networking. So it can be a case that gateway is not connected through internet to a cloud, right? So you have all the information at the gateway level. You can connect a TV and you can display that information locally. But suppose I am a grower, right? I am a owner of a company and I have 20 farms spread in different locations all across India, because I am covering 4-5 crop. I'm growing apple in Shimla or Himachal. I'm growing banana in Jalgaon. I'm growing grapes in Nashik or North Karnataka. I'm doing pomegranate in Karnataka or Maharashtra. You have deployed sensors, but all the sensors are not connected to the cloud. So I, being in Bangalore, will not be able to know what is happening in those locations. But when you connect them to the cloud using some kind of wireless communication, GPS or Wi-Fi, I can know, being in Bangalore, what is happening in those locations. That's why cloud is required. Similarly, means why do you need this Google Drive? Right? So you upload information being in Bangalore and you can access anywhere in the world. That's why a cloud is required.
Okay, sir. Sir, how artificial intelligence is important for maintaining advancement in agro-based sector?
AI is a hype, to be very frank, if you wanted to understand. So AI is in very much hype. The most of the work which is done in AI sector in India or anywhere outside is mostly image based. Image analysis. There's a company, I forgot the name of the company. They are mostly into the image analysis of the insects or the stress, right? So most of the work is done on image analysis. Not much work is done in terms of utilizing the data for doing any forecast. So again, that's like right now we are doing I cannot use because we are going to patent that. So we are doing a work in which we have collected this data from last 5 years. We are analyzing this data and then we are developing the algorithm to predict something before it happens. Right. So that's why means artificial intelligence is more like you cannot have artificial intelligence until and unless you have sufficient data, because you need to train your models. Right. That's why AI is required, and AI is definitely a future. I'm not denying the fact that AI is not a future. AI can be a future. So again, one example can be that suppose MP state government is working at MP. They have prepared different devices and they know what farmer is doing, what kind of crop at what specific date. Now they run an algorithm which can tell, okay, what amount of urea is required in a specific district. So they can plan their production of urea and they can send that urea to a specific district before the requirement comes in. But before that, you definitely need the information from the field.
Sir, will this technical advancement in towards AI will reduce the workforce?
It will not reduce the workforce. It means, let's not talk about the very futuristic 2100. Means we are still 2021. What will happen after 100 years? Nobody know, right? Probably after 100 years, you will not have the workers working in the field. You will have these robots which will till the whole field, which will put the seeds inside the field. This is happening right now, not in India, but in outside it's happening, right? Who will control the irrigation? Irrigation is controlled automatically. They will do the pruning also. They will spray also, and in the last they will do the harvesting also, but not right now.
And sir, what are the opportunities of AI and machine learning in the food industry?
AI and machine learning, you can look about AgroGrade. This is a company based in Mumbai, right? Shitish is a good friend of mine. They are using AI and machine learning to identify the quality of the crop. Similarly, Interno Labs is doing a lot of work in this field. people from Punjab will know about aging next, right? They are utilizing this machine learning using the image analysis, right? So they are mostly it's using shorting or grading. Mostly it's using shorting and grading in food industry, because again they capture the photo, they identify the crop size, crop quality, and they grade it. You can look at the AgroGrade or Intel Labs or AG Next in this regard.
Sir, is there any economic impact of this AI application of IoT devices?
Economic impact, yes, there would be, because again, what you are trying to do, means right now, again, we always keep on, when we talk to any of the investor, we always keep on taking this example that India is third number in production of cotton, but in terms of production per hectare, we are 37th number, right? So we are not able to extract sufficient production from the field. Another example is I was recently in Nasik. Although Nasik is one of the pioneers in for the grape belt, there are multiple other startups like this also who are already working over there. But still, there out of 100 farmers, 90 farmers still don't know how to use IoT and data analytics, right? So I met one farmer. He said we used to irrigate 8 hours a day for next 2 or 3 days, and he said I used to irrigate for the amount of time till when power is available, right? So he is irrigating too much, whereas that is not required. And it's happened, means if again, for human being also, somebody start drinking alcohol and start too much, right? Their body will definitely be impacted, right? Or even though if you start drinking too much of cold drink, you'll get diabetic, right? So you have to optimize the usage. Similarly, for the plant also, you have to optimize. You have to give them sufficient water so that berry cracking don't happen. At the same time, wilting don't happen. At the same time, they have sufficient water to maintain the temperature of the leaves also. Right. So, and if you are providing sufficient, if you are using all kind of scientific research, your input will definitely increase. Even though if any farmer follow package of practice published by a research institute, they can see that okay, they are producing more than what they're producing earlier. If somebody do soil testing before starting the plantation, their soil will their production will definitely increase. It's a proven fact. So it will have economic impact.
And sir, what are the security risks associated with IoT devices?
Pilferage is definitely one security risk. If somebody want to steal a device, nobody can stop them, right? Anywhere in the world, you cannot do anything for that, right? Security risk, yes, hacking happen at FBI level also, at every level also. If somebody can hack a machine which you are controlling to irrigate, they can turn on the motor, they can irrigate too much amount. So there are definitely some things are in place to avoid that kind of thing to happen.
And so what are the type of sensors that are required in hydroponics?
Hydroponics, I mentioned that in hydroponics, soil pH and soil temperature are definitely required, right? Lux is required because you are doing hydroponics mostly inside a greenhouse, right? Temperature, humidity play an important role. So I don't think that not more than this temperature, humidity, lux, soil temperature, and soil pH, not more is required. You can have others like CO2 or wind speed ventilation to make sure that sufficient amount of CO2 is present. If you are growing it into northern side of India where it's too cold or too hot, you need to have this thermostat or basically heaters which you can turn off or turn on based upon the internal environment conditions.
Thank you, sir. This is the end of the question and answer session. And we are highly elated to have you with us for this informative session. And thanks a lot for being present here.
Thank you. Thanks for giving me the opportunity. Thanks a lot. Have a good day, everyone. Bye.
And now I request Mr. Rishi to take over the.
Ruchika, next guest is not available.
Okay, sir. So this is the end of the today's session. We'll be sending you the detailed information about tomorrow's session, and stay connected and have a good day and good night. Thank you.